Hey everybody, Dr. A here, and in this video we're going to be exploring another example of angle of twist. So let's go ahead and get started. Here we're being given compute the angle of twist of the free end with respect to the fixed end of the shaft. We're being told that the shear modulus G is 4,000 KSI and the shaft is solid with a 3-inch diameter. So what we're looking at here is a fixed end A. We have an applied torque moment of 2.5 kip-feet at point B and another applied torque moment going in the other direction of 1.5 kip-feet at point C. The distance from A to B is 2.5 feet and the distance from B to C is 2 feet. So let's go ahead and start working on solving this problem. So the first thing we notice is that we have two segments of this shaft where we have constant properties and we have this abrupt change at point B here. And so what we would use here is the summation version of the angle of twist equation. So we're going to say phi equals the summation as I goes from 1 to n of TL over JG sub I. Now, what we have to ask ourselves is how many segments do we have? Well, obviously 2. So this summation can be expanded as T1L1 over J1G1 plus T2L2 over J2G2. Now, you might notice that the cross section of the shaft, it says is solid with a 3-inch diameter, which means that the cross section of the shaft is constant throughout the length, throughout the entire length, it's constant. Also, the shaft is entirely made of one material that has the shear modulus of 4,000 KSI. So because of that, we know that J1G1 and J2G2 are the same, right? J1 and J2 are the same because the cross section is the same in both segments, and G1 and G2 are again the same because you have the same material for the entire shaft. So what we can do is factor this out. We can say 1 over, and we could just call it JG times T1L1 plus T2L2, right? Now, here's the question. Where does the real work happen here? Well, we know we've got G already. That was given to us. So I'm going to check that off. We have L1 and L2 given to us, right? That's the two segment lengths there. So what we really need to get is J, T1, and T2, all right? So let's go ahead and get J first. That's a pretty straightforward calculation, right? J is the polar moment of inertia. That's going to be pi d to the 4th over 32. And again, it's a solid circle, right? So for a solid circle, we know it's pi times that one diameter to the 4th over 32. So I'm going to write this as pi times 3 inches to the 4th over 32, okay? And then what we can do is just punch this in our handy calculators. 3 raised to the 4th power is, of course, 81 times pi over 32. And so I end up getting 7.952 inches to the 4th, okay? And so there's my, my units there, right? Inches to the 4th or length to the 4th. What do we do next? Well, we can check off J. Now what we need is T1 and T2. So what I'm going to do now is use method of sections to get T1 and T2, all right? So how about this? How about we call the left segment, which is AB, we call that segment 1, all right? I'm going to call this one segment 1, and BC we're going to call segment 2. And so what we need to do is make a cut section inside each of these segments. And so T1 will be inside segment 1 and T2 will be inside segment 2. And do we need to solve for externals here? We don't need to. I mean, we could, but we don't need to because we could always look at a right free body diagram for each of these cuts, okay? So I'm going to say cut 1, all right? And I've got that shaft there. And I'm gonna put an eyeball here. And for this application, we're always gonna look inside of the cut, okay? And so I'm gonna put T1 there, and then I've got the 2.5 kip feet at B, and then in the other direction, I've got 1.5 kip feet, okay? And what do we do now? Well, we just say sum of the torques equals 0, and we're going to use that reference there, that eyeball or that viewpoint, okay? And so using this viewpoint, I'm going to say T1, and then I'm going to say minus 2.5 kip feet plus 1.5 kip feet equals 0. So what does T1 become? Well, you just move some values to the other side of the equation. You get 1 kip foot. And based on this viewpoint, what direction is this T1 going? Well, it's going to be going counterclockwise, which is the direction we assumed. And it's because this came out as a net positive, okay? What do we do next? Well, we repeat the process. We're going to say cut 2, all right? And we're going to make a cut inside that second segment there. And what's going to show up there? Well, we're going to have a T2, and again, we're going to use the same viewpoint. There's my little eyeball. Here's my little 1.5 kip feet. And I'm going to say sum of the torques using that eyeball, counterclockwise positive is 0. And so here I'm going to have T2 plus 1.5 kip feet equals 0. And so T2 is negative 1.5 kip feet. And what does that negative indicate? Well, we could write this as 1.5 kip feet, and that's going to be reacting in a clockwise fashion. So there's my T1 and T2, all right? And so now I'm ready to substitute everything in. Now you got to be careful. You got to substitute those T values in with their correct signs. So T1 will carry a positive sign and T2 will carry that negative sign, okay? So let's go ahead and substitute our values in. Again, I'm going to rewrite our equation here. Phi is equal to 1 over Jg times T1L1 plus T2L2. And so phi is going to be equal to 1 over, let's remind ourselves what was J, 7.952 inches to the fourth. 7.952 inches to the fourth. G was 4,000 KSI. Let's extend that fraction over. And then T1 is 1 kip feet times L1, which is what? L1, I believe, was 2.5 feet. And then plus T2, which is negative 1.5 kip feet times 2 feet, okay? Now, let me ask you guys a question, everybody who's watching, all right? Is this correct? Am I done? Do I just get excited and punch this in my calculator and get a final answer for phi? No, okay? You have to watch your units, okay? Let's make a note here. Make a star. Watch the units, okay? What has gone wrong here if we're not careful? Well, we have inches to the fourth, and then we have times kips per square inch. So the units of this denominator end up being kips times inches squared, right? What about the numerator here? I still have feet up here, right? I've got kip feet times feet added together. So the units of the numerator are going to have units of kip feet squared. So what have I done? I've set this up to where I have kip feet squared divided by kip inches squared. That is incorrect. That is incorrect, okay? What we have to do is convert something, all right? So how about this? How about we convert the units of the numerator to have inches built in instead of feet, okay? How are we gonna do that? Well, we just say we need to multiply that entire numerator by 12 inches over 1 foot, and we gotta square that, okay? Why? Well, because you have kip feet squared, right? Because you have kip feet times feet. So kip feet squared. So you have to convert square feet in the numerator to square inches in the numerator, all right? So you effectively multiply this entire numerator by 144, all right? And from there, you'll see that, you know, the feet will end up canceling out, and you'll have kip inches squared in the numerator and kip inches squared in the denominator. So I'm going to punch all this in, and you want to be very careful, okay? Again, don't try to punch all this in at once in your calculator, because there's a good chance you can make a mistake and make a calculator error, all right? So I'm punching it in. Now I'm dividing by JG, 7.952 times 4,000 in that denominator. And so what I end up getting is negative 0.00226 radians. Now, what does that negative indicate? That indicates I've got 0.00226 radians going clockwise, okay? Going clockwise. So remember, the idea behind this is you use the right-hand rule, and you use it as you're looking into the cut with this viewpoint. And so everything that pops out positive will be a counterclockwise rotation of your right hand, the fingers of your right hand curling into your palm in a counterclockwise fashion. So if it pops out negative, you get a negative. Of course, you get a negative if it pops out negative, but it pops out clockwise if you get a negative value. Okay, so that concludes this example. If you found this helpful, please hit like and subscribe, and be on the lookout for other examples like this. Thanks for watching.